Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study Math, Science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Physics Chapter 5 Refraction through a Lens. We will be discussing sign conventions and lens formula and problems related to it. Hope you all are ready for the session. Let's begin. First, we need to have an idea about the Cartesian sign convention which we have studied in our maths classes. Here you have the coordinate system. This is your x-axis which we represent as x, O, x dash. O is the origin. Then you have y, O, y dash which is your y-axis. This is x-axis and this is y-axis. Okay. So, values from origin along the x-axis towards the right are taken as positive. Values towards the left of the origin along the x-axis are taken negative. Then above the x-axis all the values are taken as positive and below the x-axis all the values are taken as negative. So this is the basic things in Cartesian coordinate system. Okay. Now if you have a point here, how will you measure? You will be taking the x coordinate and the y coordinate to mark the point. Okay. Now when it comes to the cases of lenses or mirrors, okay, how does it happen? Let us compare this. Here you have the x-axis. Okay, this x-axis is taken as principal axis. Okay, this is taken as principal axis. X-axis is taken as principal axis and y-axis is taken as the lens. Okay, concave or convex lens is along the y-axis. Depending on this, we have sign convention which we will be discussing now. First point is the optical center of the lens is chosen as the origin of the coordinate system. So, in a coordinate system we have studied, we have x-axis, y-axis and the point where x-axis and y-axis intersect is the center point and it is taken as the origin. So, here in case of lenses, here you have origin and this origin is your optical center. Optical center of a convex lens or optical center of a concave lens is the origin in case of a lens. Okay, so according to the sign convention, you have the center point taken as origin. Okay, with respect to origin, we will be measuring all values. Now, the second point is object is always kept on left and above the principal axis. So, here we have the principal axis. On the principal axis, you have optic center, focus, centers of curvatures, etc. Okay, now we have the optical center here. Now, when you place an object should always be placed in such a way that it is above the principal axis. This is your principal axis. Here you have the object. Okay. Object is always placed above the principal axis. With respect to the optical center, you are placing the object. So, to say the distance of the object, we will have to measure it from the origin. Okay. Now, third point, all distance are measured along the principal axis from optical center of the lens. So, with respect to optical center, we are going to measure all the distances. Here you have optical center. Okay, 2 centimeter from optical center means we will have to measure the object in such a way the object is at a distance of 2 centimeter from the origin. As we said, the object is always placed to the left of the origin along the principal axis such that the object is above the principal axis. Now, you will be having object distance. Object distance is the distance of the object from the origin. As we said, object is always to the left. Okay. So, to the left of origin along the principal axis, all the values we take will be negative. Okay. So, here all the values will be negative. Therefore, object distance which is represented as small letter u will always have negative values. Okay. This direction positive, negative, negative. Okay. So, object is always placed to the left of the optical center and it will be having negative values. Okay, first point. Now, the second point is image distance. What is image distance? The distance of the image from the optical center, which is represented by V. Okay, if the image is on the left side, then it will be having negative values. On the right side we know it is positive value. So, image distance can have negative as well as positive value. Okay, now what is focal length? Focal length, as we said, is the distance of the focus. Which focus? Second focus or the principal focus. Principal focus is the second focus. So, the distance of the principal focus or second focus from the optical center is called the focal length. Okay, when you consider the convex lens, so this is a convex lens, you can see that the second focus is this one. Second focus is to the right side of the lens, right side of the optical center. Therefore, second focus or the main focal length value f will be positive in case of convex lens. Okay, focal length of convex lens is always positive. Now, let's take the case of a concave lens. What happens to a concave lens? In case of concave lens, here we have the second focus. Second focus is to the left of the concave lens. Okay, and the value, that is, when you measure focal length, you will be getting negative value. Why? Because the second focus is on the left hand side. Clear? Okay, focal length of a concave lens is always negative and focal length of a convex lens is always positive. So, this is your third point about object distance, image distance and focal length. Fourth point, the distance measured in the direction of incident ray is taken positive, while distance measured opposite to the direction of incident ray are taken negative. Okay, now consider, here you have an incident ray. This is your incident ray. In which direction is the incident ray moving? Towards the right from left. Okay, now we have said that all the measurements are made with respect to the optical center. From optical center we will be measuring. So, in the direction of incident ray, when you measure, that is, from optical center, if you are measuring some values, you will be taking it as positive. Okay. Now, when you measure the object distance is from the optical center to where the object is placed, that is in this direction, which means opposite to the direction of incident ray. And this is the reason why we are getting always negative values for object distance. Okay. Object distance is measured from optical center to the object and the incident ray is moving from the object to the optical center, which is in the opposite direction. Okay, if you have the image formed on this side, you know incident ray is moving in this direction. Okay, image distance is measured from optical center to the image. Okay, both are in the same direction. In that case, you will be getting positive value. If the image is formed on this side, here again incident ray is in this direction and image is measured from optical center to the image in the opposite direction, which means you will be getting negative values. Okay. So, for convex and concave lens, this is the same case. You have to remember with respect to incident ray, in which direction is incident ray moving. In that direction, you will be getting values for object distance and image distance, positive or negative. Okay. Fifth point, the length above principal axis is taken positive, while the length below the principal axis is taken negative. Very simple. That is, in Cartitian coordinate, we have studied that all the values above the x-axis is taken as positive, all the values below the x-axis is taken as negative. Here, x-axis is your principal axis. Okay, x-axis is your principal axis. So, here if you have an object, so consider this case, here we have this object, this is your object. Okay, with respect to x-axis, with respect to principal axis, we are measuring and the object is above the principal axis, let's say 2 centimeter. Okay, therefore, the object height will be 2 centimeter, positive 2 centimeter. If you have the object in this way, okay, this is how the object is placed below the x-axis. In that case, you will be having negative value. Okay, object height will be negative. Mostly we will be having object height to be positive. If the image is formed above the principal axis, then the image will have a positive sign, and if the image is formed below the principal axis, then the image will be having negative sign. Clear? Now the sixth and the final one, by sign convention, the focal length of convex lens is positive and that of a concave lens is negative. We have discussed this point and we have said that U value, that is object distance, is always negative. V value can be positive or negative. Okay, when do we get positive values? Positive values is when the image is formed to the right, to the opposite side of the object or to the right of the optical center. In that case, the image formed will be real image and it will be an inverted image. If you keep a screen somewhere to focus, you will be able to get the image on the screen. On a wide screen or 2D screen, when placed, you can get the image and the image will be an inverted image. Okay. Now, if the image is formed to the left side, on the same side of the object. Okay, if object is here and image is also here, in that case you will be getting V is equal to negative. Image distance is equal to negative. In that case, the image formed will be virtual and erect. Okay, virtual and erect images will be formed. Again, about the focal length. Focal length is positive for convex and it is negative for concave. Okay, let's take a simple example. The object is placed 45 centimeter in front of a convex lens. What is the object distance? What is the object distance? Object distance is represented by letter U. Object distance U. Here we have a convex lens. This is how a convex lens looks like. Here you will be having the optical center. Given that the object is placed 45 centimeter in front of convex lens. This is in front. Okay, this is the back side. Okay. In front of the convex lens at 45 centimeter distance, an object is placed. Okay. Now what is the object distance? Object distance is 45 centimeter. Is this enough? It is placed to the left of the optical center. Okay. To the left of optical center means it will be negative. Why? Because here we have incident ray in this direction. Okay, object distance is measured from optical center to the object, which is in the opposite direction. Therefore, the sign should be negative. Minus 45 centimeter is the object distance and not 45 centimeter. Okay, so understand what the importance of this negative sign is. Clear? Second example, if the radius of curvature of a convex lens is 20 centimeter, what is its focal length? What is the relation between radius of curvature and focal length? We know radius of curvature is the distance of the optical center from center of curvature. Okay, distance between center of curvature and optical center is called the radius of curvature. What is focal length? Focal length is the distance of the optical center from principal focus. Okay, distance of the optical center from the principal focus. Now, the relation between radius of curvature and focal length is 2 times focal length will be giving you the radius of curvature. Okay. Now here it is given that the radius of curvature is 20 centimeter. In case of a convex lens, the lens considered here is a convex lens. We know for a convex lens, focal length will be positive. Similarly, radius of curvature will also be positive. Okay. Therefore, this value is positive. R is equal to 20 centimeter, which means we can write 20 centimeter. Positive 20 centimeter is 2 times focal length, and focal length will be equal to plus 20 centimeter divided by 2, and that is plus 10 centimeter. Therefore, the required focal length of the given convex lens whose radius of curvature is 20 centimeter is plus 10 centimeters. Clear? Lens formula, this is a very important equation which we will be using throughout this chapter to solve any problem. Okay, the equation relating the distance of object U, the distance of image V and focal length F of a lens is called the lens formula. Here you have to just by heart this formula, you don't need to study the derivation. Derivation is out of syllabus. Okay, now the formula is 1 by V minus 1 by U is equal to 1 by F. Okay, remember one important point, you will have to consider the sign of each. We know object distance is always negative. What about image distance V? Image distance V can be positive or negative depending on whether the image formed is a real and inverted image or virtual and erect image, where the image is formed. Okay, then F, focal length. Focal length is positive for a convex lens and negative for a concave lens. Okay, object distance is always negative, all others can be positive and negative. So this is your lens formula, 1 by V minus 1 by U is equal to 1 by F. Next is linear magnification. This is also very important. Here you can see this is an object. Okay, here the object is a tree. Object is placed in front of a convex lens. Where is the image formed? Image is formed on the opposite side. Here we have the image. What is the difference between the object and image? Object is small and the image is big, which means the image has been magnified. Okay, image is magnified. Or you can say the image is enlarged compared to the object. Okay, now let's see how this is happening. Okay, now what is magnification? What is linear magnification? It is actually a ratio. Ratio of what? The ratio of the length of image which is represented by capital letter I perpendicular to the principal axis to the length of object O is called linear magnification. Okay, you need to know the height of the image and the height of object in order to find the linear magnification. Let's say if this is 20 centimeter and this is 10 centimeter. Object is of height 10 centimeter and image is of height 20 centimeter. In that case, you will be having magnification M is equal to height of image 20 centimeter divided by height of object 10 centimeter. Now, you will have to remember very important point, the sign. Okay, here you can see the image is formed in such a way that it is below the principal axis. An inverted image below the principal axis, which means the sign will be negative. Okay, so here the image height will be negative. And the object is formed. Object is above the principal axis, so it will be having positive value. You will be getting magnification -2. It is a ratio, therefore there is no unit. Okay, so magnification M is length of image divided by length of object. Again, you have one more trick to find magnification, which is you have to take the ratio of the image distance and object distance. So magnification M is height of image by height of object. Or if you don't know this height of image and object, you can find magnification by knowing the image distance and object distance. Okay. Magnification M is equal to I by O is equal to V by U. Clear? Important points related to linear magnification. For a real image, which is an inverted image, the magnification M is negative, while for a virtual image or erect image, the magnification is positive. In the previous example, we have taken the image height to be 20 centimeter and object height 10 centimeter. Okay, we know magnification M is equal to I by O or V by U. We got magnification -20 by 10, which is -2. Okay, -2. Here you can see a negative sign. When you check this image, you can see that this image can be obtained on a screen. Real images can be obtained on a screen. It is on the opposite side of where the object is. Okay. Image formed is a real image. Real images, we know they are inverted. So here you have the object and the image formed is upside down. It is formed below the principal axis. It is an inverted image. Okay, real and inverted images formed. So that we are getting the magnification value negative. So remember, if magnification is negative, then the image is real and inverted. Okay, now let's consider the image was formed somewhere here. This is your image. In that case, let's say for the same tree, the image is formed here. In that case, we know the image formed cannot be obtained on a screen and it is a virtual image. Virtual image. Also, it is erect. Okay, same as that of the object. Erect and virtual image. In that case, the magnification value will be positive. Okay, let's consider this of height 5 centimeter. Okay, in that case, when you take magnification, magnification will be image height 5 divided by object height 10. You will be getting 0.5 and it is a positive value. Why? Because the object height and image height both are positive. Clear? Next point, the numerical value of M is greater than 1 if the image is magnified, is 1 for an image of the same size as that of the object and is less than 1 for a diminished image. Okay. So here in this case, we are getting magnification value to be equal to -2. Just check this magnitude. Don't consider the negative sign. Negative sign and positive sign says if the image formed is real and inverted or virtual and erect. Just check this magnitude value. Here this magnitude value is 2. 2 is greater than 1. Okay. If the magnification we are getting is greater than 1, it means the image formed is magnified. Magnified images are formed when the image height is greater than object height. Okay, in the second case that we have considered, that is when the image was formed somewhere here of height 0.5, magnification was 0.5, object of 10 centimeter, image formed is of 5 centimeter. In that case, we had magnification positive 0.5. Consider only the magnitude. Magnitude is 0.5. 0.5 is less than 1. Okay. Don't take this as -2. -2 less than 1. Don't consider in this way. This is wrong. You have to consider only the magnitude. Okay. 0.5 is less than 1, which means the magnification is less than 1. Okay. Magnification is less than 1. Here, the image height will be less than object height. Just consider this. Image height is less than object height. Now, consider another case. Let's say the image was formed. Here we had the object. Okay, this is your tree. And the image is formed here. Okay. In that case, you can see the object and image are of same size. If object and image are of same size, we know magnification is image height divided by object height. Let's say both of these are 10 centimeter. Okay, both of these are 10 centimeter. Here you can see a real and inverted image. Therefore, the negative sign will be there. 10 by 10, you will get 1. You have a negative sign. Don't consider this negative sign. Negative sign means it is a real and inverted image. Consider only this one. The magnitude is 1, which means magnification is equal to 1. Okay. If the magnification is equal to 1, it means they are of same size. Height of image is equal to height of object. Okay. Next point, a convex lens forms real image behind the lens. So, U and V have opposite signs. We know that in case of convex lens, both type of images are formed. Real and inverted is also formed, and virtual and erect images are also formed. We have studied the ray diagram. In the last case, only when the object is placed between optical center and focus, only in that case you are getting image on the same side. In all other cases, the image is formed on the opposite side. Okay. So, here it means that U and V are having opposite sides when the image formed is a real image. Okay. But for a convex as well as concave lens we know only virtual and erect images are formed, which is on the same side of the object. The virtual images is on the same side of the object. So, U and V have same side. Okay. So, same sign for object distance and image distance are obtained in case of convex as well as concave lens. But when it comes to the real images formed in case of convex lens, you will be having object distance and image distance having opposite sides. The last topic is power of a lens. We know that when light rays falls on convex or concave lens, what happens? It deviates from its path. We know in case of convex lens, it converges to a point, and in case of concave lens, it diverges from a point. We have studied all these in details. Okay. This deviation depends on the power of the lens. Okay. Deviation of the incident light rays produced by a lens on refraction through it is measure of its power. Okay. Let's see how. If you consider two lenses, this is first lens and this is your second lens. Okay, we have studied about thick lens and thin lens. Thick lens will be having more curvature, thin lens curvature will be less. Okay, now in this case, we know that the focal length will be short. That will be small focal length. So, here since the curvature is less, the focal length will be more. Okay, now let's see how the power depends on focal length. Power of a lens is inversely proportional to focal length, which means if focal length is short, then power will be more. Okay. If focal length is more, power will be less. For example, let's consider a convex lens, and this convex lens is having a focal length of plus 20 centimeter. We know in case of convex lens, focal length will be positive. Let's find the power. Also, remember one important point, the unit of power is diopter. Okay, diopter. One diopter is represented like this, and one diopter will be 1 meter inverse. Okay, 1 diopter is equal to 1 meter inverse, which means the focal length should be taken in meters, not in centimeter. Focal length should be taken in meters, only then you will be getting power in diopters. Okay, here we have a convex lens whose focal length is plus 20 centimeter, which is plus 0.2 meters. Okay. Then what is the power? Power will be equal to 1 by 0.2, which is 10 divided by 2. Removing the decimals, you will be getting 5. 5 diopters. Put the sign, positive sign. So in case of convex lens, you can say that always the focal length is positive, therefore power will be positive. Convex lens, power is positive. Okay. Now let's take a concave lens whose focal length is minus 20 centimeter, which is equal to minus 0.2 meters. Then the power will be equal to 1 divided by minus 0.2, which is minus 10 divided by 2, minus 5 diopters. So when you have a concave lens, for a concave lens, power will be negative. Why? Because power depends on focal length. If focal length is negative, then power is also negative. Clear? Understood? Now, if you have combination of lenses, if you take a convex lens and concave lens, okay, power of the convex lens, let's say, is equal to plus 5 diopter, and that of concave lens power is equal to minus 5 diopter. Okay, for combination of lens, if you need to find the power, then power will be equal to power of first lens plus power of second lens. If you have two lenses, you will have to add the power of all these lenses, you will be getting the total power. In this case, we will be having plus 5 diopter plus minus 5 diopter, which is equal to 0. Power will be 0 diopter. Okay, when you take convex lens and concave lens of equal power but opposite sign, then you will be getting power 0 diopter, and they will be just acting as a simple glass slab. Okay. They will be acting as a single glass slab. If you have n number of lenses, then the total power will be equal to P1 plus, P2 plus, P3 plus, etc. up to Pn. Okay. Just take the algebraic sum, you will be getting the power. Clear? Let us now solve problems using the lens formula and magnifications. An object of height 4 cm is placed at a distance 24 cm in front of a convex lens of focal length 8 cm. Find the position and size of the image. Second part, state the characteristics of the image. Okay, given an object of height 4 cm. Object height O is equal to 4 cm. Is placed at a distance of 24 cm. What is this 24 cm then? It is placed in front of a convex lens at a distance of 24 cm, which means the object distance U is given, which is 24 centimeters. Now using the sign convention, we know that anything to the left of the lens will take negative values. Okay, to the left negative, to the right positive. Upwards you will be having positive value, downwards will be having negative values. Upwards of the principal axis and downwards of principal axis. Okay, so minus 24 centimeter. Now the focal length is given. Focal length is equal to 8 centimeter. We know focal length of a convex lens is positive and that of a concave lens is negative. Okay, F is equal to 8 centimeter. So first part we have to find the position and size of the image, which means the object distance we have to find and the height of image we have to find. First, let us find the object distance. For this, we can use the formula, lens formula. 1 by F is equal to 1 by V minus 1 by U. Okay, this is the formula. We need 1 by V. Okay, so 1 by V will be equal to 1 by F. Taking this minus 1 by U to the opposite side, it becomes plus 1 by U. Now, put the values. 1 by V will be equal to 1 by F. F is 8 centimeter. Then plus 1 by U. 1 by U is negative 24. So remember to put this minus sign or you will be getting a very different answer. Okay. 1 by 8 plus 1 by minus 24, which is 1 by 8 minus 1 by 24. Taking the LCM of 8 and 24, denominator will be getting 24. 8 into 3 is 24. 3 into 1, 3. Minus 1 into 24 is 24. 1 into 1, 1. Which is equal to 2 by 24. 1 by V is 2 by 24. Which means taking the reciprocal, V will be equal to 24 divided by 2, which is 12 centimeters. Okay. Object distance, we have minus 24 centimeter. 24 centimeter, negative sign because it is in the left. Here we are getting positive 12 centimeter as the image distance. Positive means it is on the right side of the lens. Okay, so we got the object distance. Now we have to find the size of the image. To find size, we have magnification is equal to image distance by object distance, which is equal to height of image divided by height of object. Okay. Now we have the value of V. V is 12 centimeter, U is minus 24. Then we have our object height 4 centimeter. We can find the image height. I will be equal to object height into V divided by U. Object height. Object height is equal to 4 centimeter. 4 into V is 12 centimeter. U is minus 24 centimeters. So here you will be getting 12, 24 can be cancelled. We get 2, 2 and 4 cancelled. 2 minus 2. Okay. Minus 2 centimeter. What does this mean? 2 centimeter is the height of the image. Okay. Negative sign shows that the image formed will be an inverted image. Okay. An inverted image will be formed below the principal axis. Now we have to state the characteristics of the image. What are the characteristics of image? Check the value. Here we have object to be of height 4 centimeter and the image is of height 2 centimeter. If you find the magnification, M will be equal to 2 divided by minus 2 divided by 4, which is minus 0.5. Okay, we are getting magnification to be a value. Just check the magnitude. Magnitude is 0.5, which is less than 1. Okay, if magnification is less than 1, then the image will be diminished. Okay, smaller than the object. It is clear, right? Here it is 2 centimeter. Image height is 2 centimeter and object height is 4 centimeter, which means the image is diminished. Okay, next, here we have a negative sign. What does this negative sign mean? The formed image will be inverted, okay, below the principal axis, and also inverted images are always real. Okay, real, inverted and diminished image will be formed. What about magnification? Magnification value is 0.5. Clear? Second problem, at what position a candle of length 3 cm be placed in front of a convex lens so that its image of length 6 cm be obtained on a screen placed at a distance of 30 cm behind the lens. Also, we have to find the focal length of the lens in part A. Okay, here what is given? We have to find at what position a candle is placed, which means we have to find the object distance. What is given? Length 3 cm, which means object height is given 3 cm. Be placed in front of a convex lens. For a convex lens, we know real and inverted image as well as virtual and erect images are formed. So that its image length is given, image height is equal to 6 cm. Okay. Now, it is given that the image is obtained on a screen placed at a distance of 30 cm behind the lens. So, when you have a convex lens, the image may be formed in front of the lens or behind the lens. Both cases are there. So, first 5 cases, that is object placed at infinity, object beyond 2f1, object at 2f1, object between 2f1 and f1, object at f1. In all these cases, we will be getting the image being formed on the right side, which means behind the lens. In all these cases, we are getting real and inverted images. Yes, we are getting real and inverted images. For real and inverted images means this is how the image will look. Okay, the image is below the principal axis, which means we have to take the height of image negative. Okay, so here it is said that the image is formed behind the lens, which means the image formed will be a real and inverted image. Therefore, we will be taking the image height to be a negative value. Clear? If it is formed on the same side, that is in front of the mirror, in that case, what do we get? You will be getting a virtual and erect image. It will be positive. So here it is mentioned that behind the lens. Okay, behind the lens means the negative value will be there. Okay, next, V is also given, which is the distance of the image from the lens, which is 30 centimeters. It will be positive because towards the right or behind the lens the image is formed. Now we can find the object distance U. We have magnification M is equal to V by U, which is height of image divided by height of object. Okay. Now we know the value of V. We know what I is and what O is. Therefore, you can write U will be equal to cross multiplying O into V divided by I. O. O is equal to 3 centimeter. V is 30 divided by minus 6. Never forget the negative sign. Cancelling. Here you will be getting minus 2. 30 divided by minus 2. That is minus 30 by 2, which is minus 15 centimeters. Okay. U is equal to minus 15 centimeters. Negative sign, which means the object is on the left side of the lens. Okay, 15 centimeter is the object distance. Next, we have to find focal length. We have 1 by f is equal to 1 by v minus 1 by u. Put the values. 1 by f is equal to 1 by v. V is 30 centimeter minus 1 by u. U is minus 15. So, negative into negative becomes positive. 1 by 30 plus 1 by 15, taking LCM, we get denominator 30. Okay, 30 into 1 is 30, 1 into 1, 1, plus 15 into 2 is 30, 2 into 1, 2. Okay, 3 divided by 30, which means taking the reciprocal, focal length will be equal to 30 divided by 3, which is 10. Focal length is 10 centimeter. Positive focal length, because this is a convex lens. When you get the value, if you are finding the focal length, you should get positive value, because in case of a convex lens, focal length will always be positive. Okay, focal length is 10 centimeter, positive 10 centimeter, and the object distance also we have determined, which is minus 15 centimeters. Okay, next problem number 3. The power of a lens is plus 2 diopter. Find the focal length and state the kind of lens. We have a relation between power of a lens and its focal length. Power is equal to 1 by focal length. Okay. Unit of power. Power will always be given in the diopters. So, here power is given, which is plus 2.0 diopter. How to find focal length? If P is equal to 1 by F, then F will be equal to 1 by P, 1 by power, that is 1 by plus 2. Okay, what do we get? 1 by 2 is equal to 0.5, 0.5 meters. Remember, the unit will be meter. Okay, focal length will be 0.5 meter. Now we have 1 meter is equal to 100 centimeter. Then what is 0.5 meter? 0.5 meter will be 0.5 into 100 centimeter, which is 50 centimeters. Okay, we have determined the focal length. Focal length is 50 centimeter. Now remember, you have to put the positive sign. Since the power is positive, focal length will also be positive. Positive focal length, concave or convex? Yes, convex lens. So the lens used here will be a convex lens. We are getting positive focal length. Since the focal length is positive, the used lens will be a convex lens. Problem 4. A concave lens forms an erect image of 1 by 3rd the size of the object, which is placed at a distance 30 centimeter in front of the lens. Find A part the position of the image and B part the focal length of the lens. So here we have a concave lens. Concave lens means the focal length will be negative. If we are taking the height of object, if height of object is equal to some O centimeter, height of object is O centimeter, then the height of image will be 1 by 3rd that of the height of object. 1 by 3 into O centimeter or O by 3 centimeters. Okay, O by 3 centimeters is the size or height of the image. Is it positive or negative? Here we have an erect image. Erect image means the image is formed above the principal axis. So above the principal axis, positive values. Positive value. Okay. Also it is given that which is placed at a distance of 30 centimeter. Object distance U is given 30 centimeter. Object distance will always be negative. Okay. Find the position of the image. We have to first find V. How to find V? We have magnification. M is equal to V by U, which is height of image divided by height of object. Okay. Here the height of image is equal to height of object divided by 3. Okay. So we have V by U is equal to I by O. We have to find V. V is equal to I into U divided by O. I is O by 3. O by 3 into U is equal to minus 30 centimeter. Minus 30 divided by O is equal to, O is taken as the same. O is taken as the height of the object. Okay. O and O can be cancelled. Then we get minus 10 centimeters. Minus 10 centimeter. What does it mean? Negative sign. Therefore, the image will be formed in front of the lens. Okay. We have to find the focal length of the lens. How to find focal length? 1 by F is equal to 1 by V minus 1 by U. Put the values. 1 by F is equal to 1 by minus 10 minus 1 by minus 30. Okay. Which is minus 1 by 10 minus of minus plus 1 by 30, that is equal to, taking LCM denominator we get 30. 10 into 3 is 30. 3 into minus 1, minus 3 plus 30 into 1 is 30. 1 into 1, 1, which is equal to minus 2 by 30. Minus 2 by 30. Taking the reciprocal, F will be equal to minus 30 divided by 2, which is minus 15 centimeter. Now check here, we are getting the focal length to be negative, given that the lens used is a concave lens. So it is confirmed that since for a concave lens, we know focal length is negative. Once you get a negative value for focal length, you can confirm that it is a concave lens. Okay. Problem number 5. A lens forms the image of an object placed at a distance of 45 cm from it on a screen placed at a distance 90 cm on the other side of it. A part, name the kind of lens. B part, find the focal length of the lens and the magnification of the image formed. Okay. Here what is given? A lens forms the image of an object placed at a distance of 45 cm. Object distance U is given, which is minus 45 centimeter. From it on a screen placed at a distance of 90 centimeter, V is equal to 90 centimeter on the other side of it. So the first part of the question is we have to name which kind of lens it is. Since the image is formed on the opposite side, what does it mean? We know in case of a concave lens, image is always formed on the same side of the object. In which side object is placed, on the same side image will also be formed, and the image formed will be virtual and erect. Now here it is given that the image is formed on the other side or the opposite side, which means the lens should be a convex lens. Okay, since image is formed on the opposite side or behind the lens used will be a convex lens. Now the second part, we have to find the focal length of the lens. We know the value of U and V, can easily find what is focal length. 1 by F is equal to 1 by V minus 1 by U. 1 by F is equal to 1 by 90 minus 1 by minus 45, which is 1 by 90 plus 1 by 45. Negative of negative becomes positive. Okay. 1 by F is equal to, taking LCM, we get 90 in the denominator, numerator. 90 into 1 is 90, 1 into 1, 1, plus 45 into 2 is 90, 2 into 1, 2. 1 plus 2, 3 divided by 90. 1 by f is equal to 3 by 90, which means f is equal to 90 by 3. What is 90 by 3? 30. Okay, 30 centimeter is the focal length. We are getting positive value. Again, confirm the lens that is used is a convex lens since the focal length is positive. Okay. Next, the second part, we have to find the magnification of image. Magnification m is equal to v by u or height of image by height of object. Here we don't know the height of image or the height of object. We have the value of v and u. Therefore, magnification m is equal to v. V is 90 centimeter divided by u. U is minus 45. Okay. That is minus 90 by 45 minus 2. Okay. Since magnification is a ratio of same quantities, there is no unit for magnification. We are getting minus 2. Negative sign shows that the image formed is real and inverted. Okay. The value. Now check the value. Magnitude. Magnitude 2 is greater than 1. Therefore, the image formed will be magnified. Okay. If the magnitude is less than 1, the image is diminished. If the magnitude is greater than 1, the image will be magnified or enlarged. Clear? Next, problem number 6. Where must an object be placed in front of a convex lens of focal length 20 cm to obtain a real and 4 times magnified image? Where will the image form? Here, we have to find where must an object be placed in front of a convex lens, which means we have to find the object distance. Focal length is given, f is equal to 20 centimeter. To obtain a real and 4 times magnified. Magnification is given, which is 4. Okay. It is given that the image formed is real. What does it mean? We have said that magnification for real and inverted images, magnification will be negative. Okay. Virtual and erect images, magnification will be positive. Why? Because in these cases, the image is formed. In case of real and inverted images are formed below the principal axis. Below the principal axis, the value will be negative. Okay. Magnification is minus 4. Now, we have to find u. How to find u? We have 1 by f is equal to 1 by v minus 1 by u. Okay. We just know only the value of f. To find u, we need the value of v. Okay. We have magnification m is equal to v by u. Okay. V by u value we have, what is it? Minus 4. Minus 4. If v by u is equal to minus 4, then we can write v is equal to minus 4u. Just cross multiplying. Taking this u to the opposite side, numerator, we get v is equal to minus 4u. If v is equal to minus 4u, substituting here, 1 by f is equal to 1 by minus 4u. In place of v, I am putting minus 4u minus 1 by u. Okay. We know the value of focal length, which is 20 centimeter. 1 by 20. Given it is a convex lens, for a convex lens, focal length is positive. Equal to, taking LCM, we get minus 4u in the denominator. Minus 4u into 1 is minus 4u. 1 into 1, 1. Minus, here we have u. U into minus 4 is minus 4u. Minus 4 into 1, which is equal to minus 4. Therefore, here we get minus 4. Okay. 1 minus minus 4, which is 1 plus 4 divided by minus 4u, which is 5 by minus 4u. Okay. 1 by 20 is equal to minus 5 by 4u. Taking this 4u to the opposite side, 4u is equal to minus 5 into 20. U is equal to minus 5 into 20 divided by 4. 4 and 20 can be cancelled. We get 5 here. 5 into 5 is 25 minus 25. Object distance will always be negative. Now the second part of the question, where will the image be formed? Which means we have to find the image distance v. V is equal to minus 4u minus 4 into minus 25. Minus into minus is plus. 4 into 25 is 100. 100 centimeter. At a distance of 100 centimeter, behind the lens, the image will be formed. Clear? We have determined the object distance and image distance. Here we have the last problem, problem number 7. An object is placed at a distance 24 cm in front of a convex lens of focal length 8 cm. What is the nature of image so formed? Calculate the distance of the image from the lens, which means the image distance V we have to determine. Then calculate the magnification of the image. M we have to find. Okay. First we need to find what is the nature of the image so formed. An object is placed at a distance 24 cm in front of a convex lens. Object distance is given. Object distance U is equal to minus 24 cm. Negative sign. Okay. Then in front of a convex lens, which means in focal length in this case will be positive. Why? Because it is a convex lens. Focal length F is equal to plus 8 cm. First question, we have to find what is the nature of the image so formed. Okay. So here, focal length is given, object distance is given. We can find image distance. In order to determine the nature, nature means what and all we have to find? We have to find whether it is a real image or it is an inverted image. It's a virtual image or erect image. Just by constructing a ray diagram also you can find this. This is a convex lens. Here we have optic center. Okay. This is the focal point F1. Here you have F2. Okay. Where is this distance from the focus to the optical center is given, which is 8 centimeters. Okay. Where is the object placed? Object is placed at 24 centimeter. This is 8 centimeter. 2. Here you will be having 2F1. Okay. So this total distance will become 16. 24 is beyond this. So here we have the object. Okay. So this is the position of the object. 24 centimeter from the optical center. Okay. This total distance is 24 centimeter, which means the object is placed beyond 2F1. In that case, where is the image formed? We have studied the image formation. Here you will be having F2. Here you will be having 2F2. Okay. When light rays comes from infinity, they will go to the principal focus. So when light rays are coming from the beyond 2F1 point, where is the light rays focused? The light rays will be focused at a point which is between F2 and 2F2. We have studied the image formation. Here the image formed will be a diminished image. Then the image formed will be real and inverted. For the first question, the answer is real and inverted. We know in case of a convex lens, only when object is placed between optic center and the first principal focus, only in that case you will be getting the image formed to be virtual. In all other cases, you will be getting the image formed to be real and inverted. Okay. Now the second part of the question, we have to calculate the distance of the image from the lens, which means we have to calculate V. Okay. We have the lens formula 1 by F is equal to 1 by V minus 1 by U. To find 1 by V, you will be having 1 by F plus 1 by U. Taking this minus 1 by U to the opposite side. Put the values. 1 by V is equal to 1 by F. F is 8 centimeter plus 1 by minus 24. Okay. 1 by V is equal to 1 by 8 minus 1 by 24, which is taking LCM 24 in the denominator. 8 3s are 24. 3 into 1 3 minus 24 into 1 is 24. 1 into 1 1. Okay. Therefore 1 by V is equal to 2 divided by 24 and V is equal to 24 divided by 2, which is 12 centimeter. Positive 12 centimeter. Okay. Next, the third part of the question, we have to find the magnification. Magnification can be determined if you know the object height and image height, or take the ratio of object distance and image distance. Okay. Here, image distance is 12 centimeter, which we have determined. Positive 12 centimeter, and the object distance is minus 24 centimeter. Minus 24 centimeter. Okay. Negative sign will be there. When you take the ratio 12 by 24, 12 by 24 is 0.5. So minus 0.5. 0.5 is a value which is less than 1, which means magnification is less than 1. Image formed will be a diminished image. Okay, just for confirmation, you are getting a diminished image. Also, we are getting a value with a negative sign. This negative sign shows that the image formed is real and inverted. Understood? That's all for today. In today's class, we have discussed sign convention, lens formula and power of a lens. Hope you all enjoyed the session. We have also solved many problems related to it. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.